or if you look at this carbon, if you look at the carbon, is in reality a condition of it, which is 6 of the hydrogen, deuterium, sorry. You understand?
Yes.
So now you have 6 of deuterium. What's the size of this? What the ratio is the ball? And how you can place it as a ball itself. And then if you go a step back on it, if you can create a hydrogen, and then you create a deuterium and you can correct it tritium. But if you confine it within what do you call a carbon, so your gradient becomes very massive, doesn't it? The rotation in the first and the second core is inevitable. It'll happen.
Yes, it's this basic simple reactor, this what we would call a static reactor, because it's created a field of 6. It already has all the ingredients that we use later on. My understanding is that we then need a gradient, a plasmatic field difference with another GaNs or metal
Okay, now we go
condition.
back. You brought something up which I explained years ago. Now we go to it. Because I think if you are matured into it, the rest have to understand. We go back to one of the first boxes of the CO2 boxes, which the design was done this way, which we could put different plates on different condition of it, correct? If you remember.
Yes.
So if you remember, this is the zinc, for example, and this is a copper, yeah? So if you put a ball here of in the middle, so you have in it a carbon, correct?
Mm-hmm.
Carbon, by order of the plasma strength, it goes in the center, yeah?
Yes.
Now you have a carbon, you have another, sorry, you have the copper here. Now you add a zinc ion, yes,
Yes.
which now this gives you a H3,
Yes.
correct?
Yes.
So your hydrogen sits here. This is your tritium, correct?
Yes.
Now you have to choose another material on this side of the board. Yeah, we have this one here, and then you have the option to choose another material here, and then you have an option to choose another material here, correct?
Yes.
The choice of the option, because here you're still creating the carbon here as a carbon denominator, because you chose, the only nanomaterial you chose was the copper, yeah? So
Mm-hmm.
the rest you are playing with metals, correct?
Yes.
So the next material you have to consider, you already received your carbon, you already, that's 12, or what do you call it, let's say on the proton sides, yes? Um, no, we put on the system of the energy, it's easier. Let me take,
Plasmatic field strength, let's say
yeah,
6.
we put it on a plasmatic field strength, okay? Um, I have to go here to get it back. Okay, so now we have the carbon in the middle. Sorry, the carbon is blue. We have the carbon in the middle. We have tritium outside it. Now we need to get the deuterium. How can we get the deuterium? Which is 1,
2.
1, and 1. Yeah? So do what Giovanni does. Sit down and balance it out. Yeah? So now your reactor has become totally plasmatic. So what you're gonna do, let's say you choose a material which becomes deuterium, correct?
By totally
You need,
plasmatic, you mean it's in the Caroline core state?
everything is in the Caroline core state. So now you have found the fourth material, okay? And this is the fourth material. Now, you need hydrogen. Where is your hydrogen going to be? Yeah? You need this here. So you need the hydrogen because it's of the lowest order to sit here. So you have a choice of two more metals, or combination of the fields of these gives a condition. You have to remember one thing: zinc, zinc. Yeah? What is the zinc plus something, or a zinc plus something, or a zinc plus something, which can give you this?
Yes, I understand.
You understand?
Composite material.
One of your best option to create a hydrogen on its own, which is one electron, one proton, which you're looking for a neutron. In reality, energy fields of a neutron is very simple. You need a copper, because somewhere in the field spectrum of the copper and nano copper coated, there is a release-free hydrogen.
The isotope.
Pardon? Yeah, one of its isotopes.
Yes, yes, yes.
You understand? So now what you have a gradient difference between the inside and outside. It will turn 100% the deuterium, and it will turn the tritium. Tritium will become the feeder of the, what do you call it, the feeder of the energy. The carbon in the middle, because of its plasmatic condition, it becomes a reflector. Then deuterium plays the game of carbon, gives you solidification. And then you get the motor rotating. It gets your plasma rotating.
Yes, and then we need to understand how to control the system, because
Very easy, extremely easy. Extremely easy.
we have an effect on the systems, and up until
You
now
can,
we've been
you
training this.
have, let me explain to you. You have within your position your amino acid. You still have that carbon dominator here. And then you have the connection of the hydrogen with it.
So we move it like our hands?
By emotion.
Yes, by our will.
Yes.
And this is why we should pray to the reactor, give our magnetic field. So
Yeah,
that
the thing is, this is a totally plasmatic. This is one of the reasons in the teachings of the original GAN system. Always, if you go back in the recordings, many times, 3, 4 times I refer to it, and so people are not ready for it, they don't understand. If you look at one of the original designs, we had brackets here, you could put material behind to change gases. But now, I always say, when somebody understands part, I explained all of it. So in fact, if you put a ball in here, you don't need to do anything else. You can contain it, and this becomes your, what do you call it, plasma field holder. But you need deuterium, especially 6 to 1, but it's an order of magnitude. But you have to go back on the carbon plasmatic magnetic field, which is the order of magnitude of 100 and, yeah, it's 120 to 1 compared to the hydrogen. So it's a huge power point to create lift and shift. But if you can create this condition in 3 levels, then you have to find how you can feed this up to do it. This is what I said in the discussion few minutes ago, half an hour ago. You have to develop tools to achieve what you want to achieve. You just half it, you don't know what to do with it, it's no good.
This system,
You understand?
yes, this system alone can fly.
Yes, but where do you want to fly to? Where is your protection? You like to sit on the chair going nowhere. This has been tested for millions of years, but if you don't understand it, you cannot do much with it. Because you actually can create, if you understand the process, you can create subatomic, subnuclear, and then use the neutron as a feeder. Because when you go into the structure of the atomic physical structure, I lost it, let me get it back. When you go deep into the structure of the nuclear and nucleus process, it's not just the plasma, it's the combination of plasmas. And if you can understand, this is what I explained, when man goes further to understand creation of the plasma from the plasma, is when you reach the total maturity of universal transportation. But you're not there. There's no use explaining it to you.
In the universe, we will not have nothing else but the fields to work on. We
Other
will not
fields.
have any matter.
In the dimension of what we call we travel above this. This is what are called, just means when you travel within the plasma of the plasma. Because neutron then is a plasma itself, but you can create the plasma of the neutron and understand the subdivision of it, then you're in different realm of real world of creation of a speed. But what I said, I teach man everything. That when it comes to space, is not falling behind. It doesn't come in slave, but man chooses to slave.